Hello students, we will start with a new topic in measurements and instrumentation. So you're going through a tough time. Hope you're all safe there. Just stay home and break the chain. So we'll start with instrument transformers. So you'll know what are transformers. We will study about instrument transformers here. So hope you all know the working of ideal transformer. So there's a primary winding and a secondary winding. If we connect a alternating voltage V1 at the primary, so a voltage V2 will be induced at the secondary by mutual induction, and hope you all know the voltage and current relations. So what are instrument transformers? So basically how can we use transformers for measurement purpose? So that's the answer. If you want to measure a very high AC voltage, say we want to measure some 10 kV voltage and we have a voltmeter of limited range in hand, say we have a voltmeter of 0 to 10 volt. In that case, can we use this 10 volt voltmeter for measuring 10 kV? No, we cannot. Then what can we do? What we can do is we can step down this voltage using a transformer and then measure this, right? So that is the idea behind instrument transformer. So we will see this. So say we have an AC source or an AC voltage to be measured. So we will connect this to the primary of a transformer, and here we are using a step down transformer. At the secondary side we are connecting the voltmeter. So here the voltage to be measured is a high voltage 10 kV and the voltmeter is a low range voltmeter of 0 to 10 volt. So if maybe we can choose the turns ratio as N1 as 1000 and N2 as 1. So in this case, this transformer is called a potential transformer. Here we are stepping down the voltage. Again, V1 is the voltage to be measured, the high voltage to be measured, which is connected to the primary, and V2 is measured by the voltmeter V. So if it is 10 kV, V1 is 10 kV, then V2 is given by the voltage relation of transformer. We will get it as 10 volt. V2 equals V1 into N2 by N1. So that is 10 volts. So basically a potential transformer brings down this high voltage to a measurable value, measurable low value. So that is the purpose of a potential transformer. So now we will see a current transformer. Assume we have a transmission line or a conductor which carries a high current, say 1 kiloampere current, and if you want to measure this current using an ammeter, and say we have a low range ammeter in hand, assume we have a 0 to 1 ampere ammeter in our hand. So can we just open the circuit and connect this 0 to 1 ampere ammeter or this maybe 0 to 10 ampere ammeter simply in series? No, that is wrong. We can't use this ammeter. Then what is the solution? So there comes the instrument transformer, or we will call it a current transformer. So what we will do is we have this line carrying high current, say 1 kiloampere. So what we will do is we will connect the primary side of a current transformer to this transmission line, maybe over the conductor carrying a high current, and now to the secondary of the transformer we will connect the low range ammeter 0 to 10 ampere or 0 to 1 ampere ammeter at the secondary side. By properly choosing the turns ratio, we can actually adjust the range or change the range of the meter. So here you can see the current should be low at the secondary side. So you know the current relation of a transformer, I1 by I2 equals N2 by N1, right? So we can by properly choosing N1 and N2, we can measure high current using a low range ammeter. That is the idea behind a current transformer. So yes, we saw this. Now in this case, this transformer, we will call it as a current transformer. So at the primary side, it carries 1 kiloampere current, and at the secondary side, we have a low range ammeter of 0 to 1 ampere ammeter. So you know, if I1 is 1 kiloampere, I2 will be given by I2 equals I1 into N1 by N2. So if we choose N1 as 1 and N2 as 1000, we will get I2 as 1 ampere. So eventually CT brings down this current value so that we can measure with a low range ammeter. Now advantages of CT, again the ease with which we can change the range, low power loss, low burden voltage, we can insert or replace meters easily. Again it can be used to connect relay, circuit breakers, etc. Eventually, or in a sense, relays, CBs, etc. actually sense or measure the current value. So we will discuss these points in more detail later. Again, potential transformers also have these advantages. Again, they have less power loss in the meter, offer higher internal impedance, and easy to insert or replace the meter. And again, they can be used to connect relays or circuit breakers, etc. So with this we will wind up this video, and we will discuss instrument transformers in more detail in the coming videos. Thank you.